All right. Chemistry students, we start 1B today. We did 1A in the last class. 1B is the classification of matter. And remember, we should know what matter is, plus many other Unit 1 vocab words. So let's get into this. Pure substances. New vocab word is anything that has the same composition and the same properties. So I have some pictures of some pure substances, very tiny. Have you seen sodium metal before? That's what sodium metal looks like. That's a pure substance. Just to the right of that, I have chlorine gas, and chlorine gas would be a pure substance. When I mix sodium metal with chlorine gas, a reaction occurs to make sodium chloride, which you better know as salt. And every single one of these would be a pure substance. So a pure substance could be an element like sodium or chlorine or gold. And then a pure substance could be a compound also, like sodium chloride, glucose, sugar, water, and there are many other examples. So, question: out of these three pictures, A, B, and C, which are the pure substances? And just going to let you look at that for a second so you can answer in your head. So right now, have an answer in your head: A, B, or C. All right. Answer. A is not a pure substance because we have a mixture of the blues and the reds, and they're separate, so we would call that a mixture. B is a pure substance because all we have are the reds. And then C, yes, is a pure substance also because everything in C is a blue bonded to a red. So B and C are the pure substances. And that leads us to the A picture, a mixture. A blend of two or more types of matter, where each component keeps its own identity and properties. The components are physically mixed, and they can be separated using physical means. So, homogeneous or homogeneous. You can pronounce it either way. We also, if in solution or mixed with water, we will call it a solution. It looks like it's uniform. It looks like a pure substance, but it's not. There's no visible parts. It is truly a mixture. So some examples. Vinegar, which is down here in the right-hand corner, is a mixture of acetic acid and water. And it's usually 10% acetic acid and 90% water. Clear air. The air in this room is a mixture of nitrogen and oxygen and carbon dioxide and water and argon. Salt water is a mixture of salt and water, obviously, sodium chloride and water. And then down here, an example of a solid mixture, an alloy, where many alloys we mix together two metals to make it so those metals don't react with oxygen in the air. So brass is an example. I believe brass is a mixture of copper and zinc metal. Homogeneous. Heterogeneous or heterogeneous. Not uniform in composition. Oftentimes you can see visible parts, visible differences. Soil So soil will be made up of dirt, tiny pebbles, maybe rocks, clay, etc. And you can usually see those differences. Concrete is often made of kind of the same thing as soil, many different sizes of rocks, and then kind of a cement type glue to hold those rocks together. Blood is more difficult to see. You would need a microscope to see that blood is a mixture of plasma, red blood cells, white blood cells, and platelets. And then the chocolate chip cookies, the picture is M&M cookies. You can definitely see different colors of M&Ms. You can see the flour parts, the chocolate chips in the cookie. Sand or sand and water. This is a picture of sand. Sand would have millions of different types of tiny little rocks. And then iced tea. But you have to have the ice. So you can see the ice and you can see the tea. That would be heterogeneous. If I just had tea, you could maybe say that that tea was homogeneous. So let's take another quiz. What type of mixture is each of these pictures? Let's start with A, granite. And granite is a rock, very common rock. And you can see a close-up of the rock. It's made up of many different types of minerals with these different colors. We already said blood is a heterogeneous because blood is a mix of red, white blood cells and plasma. Copper 2 sulfate is uniform. You can't see any difference in the copper 2 sulfate, so that's a homogeneous mixture. Here's a little flow chart just to show the difference between all of these vocab words that we've hit so far in Unit 1. So you can see matter is everything, right? Chemicals would make up that matter. All chemicals are matter. And then we have pure substances, which are elements and compounds on the left. And then we have mixtures on the right, which are homogeneous or heterogeneous. And then some other examples for all of those things we just talked about on the last 4 slides. All right, with mixtures, how do we separate out mixtures? So I want to talk about some techniques of mixtures. Filtering is where we take a setup to the right, an Erlenmeyer flask at the bottom, a funnel, and then filter paper. And we have a solution, a heterogeneous solution, and we pour the heterogeneous solution through the filter paper, and the solution falls to the bottom, and the solids get caught by the filter paper. So maybe we have sandy water. The water would flow through into the beaker, and the sand would be left behind. And that would be our filtration separation technique. Vaporization is a little bit different, and I don't have a picture of this, but say we have some salt water. We can separate the salt from the water by evaporating the water. So we would get like a watch glass and pour some salt water on it and heat it up, and all the water would evaporate, and what would be left behind on the glass would be pure salt. Chromatography, paper chromatography, is used to separate mixtures because they move quicker or slower on a piece of chromatography paper. So, down here in the pictures, we have taken a marker, a black marker, and we've dipped it in a solvent, and we've waited about 2 minutes to let that solvent run up the paper. And as the solvent runs up the paper, all of the colors that make up that black marker are separated. Did you know that a black marker is a mixture of yellow and red and purple and blue? Well, now you know that there's a lot of colors that make up that black marker. Decanting is basically pouring off a solution and leaving the solid behind. And you can see the technique to the right. Say I have rocks in water or pebbles in water, and I want to pour all the water off and leave the pebbles behind. I would take my Erlenmeyer flask and a stirring rod and place the stirring rod over the end of the flask. The water will flow out down the rod into the beaker, and the stirring rod would also help to keep the pebbles in the flask if they would happen to want to try to jump out of the flask. Pebbles left behind, water in the beaker. That's decanting. Centrifuge, I don't have a picture of. Centrifuge, you have to have a special machine. It's a machine that spins in circles really quick. And it will, when it spins for about a minute, it will separate out a solution based on density. This is almost always done with blood samples. So you would find centrifuges in labs where you put your blood sample in a test tube, you put it in the centrifuge, you spin it for about a minute, and it will separate out the plasma from the red blood cells from the white blood cells in different layers in your test tube. All right, that's our Unit 1, 1B presentation. Talk to you guys later.